66 years. That's how long sonar equipment has been pointed into the black water of Loch Ness, searching for something nobody's ever been able to definitively prove exists. 6 different decades of expeditions, dozens of separate research teams, military-grade sonar arrays, commercial fish finders, cutting-edge robotic submarines, and across every single one of those 66 years, one thing keeps happening that nobody has ever fully explained. Unexplained contacts. Large moving objects showing up on sonar screens deep in the loch, in places where nothing should be. Now, all of that scattered data, everything collected since the very first serious sonar sweep back in 1968, has finally been pulled together and run through modern AI analysis. And the pattern that came back has left even skeptical researchers admitting they don't have a clean explanation. Stick with me, because this one goes deeper than you'd expect. And if you want more of these deep dives into evidence nobody's ever properly connected before, subscribe now. First, let's get the real history straight, because the story of Loch Ness sonar research goes back a lot further and involves a lot more serious science than most people realize. The loch itself sits in the Scottish Highlands, stretching about 23 miles long, and it is astonishingly deep, plunging to roughly 755 feet at its lowest point, deep enough to hide almost anything and keep it hidden. Stories about something unusual living in these waters go back centuries, with the earliest recorded account tracing to an old legend involving the Irish monk, St. Columba, around 565 AD, who supposedly encountered a large creature in the River Ness. But the modern era of the mystery really kicked off in 1933, when a wave of sightings, followed by a blurry photograph published the following year, turned Loch Ness into an international phenomenon almost overnight. That photo, the so-called surgeon's photograph, was eventually exposed decades later as a hoax involving a toy submarine, and that single debunking has shaped a lot of public skepticism about the whole mystery ever since. But here's what usually gets lost in that story. Serious, credentialed researchers didn't stop investigating just because one famous photo turned out to be fake. In 1968, a team from the University of Birmingham, led by researchers Braithwaite and Tucker, conducted one of the first real scientific sonar surveys of the loch, and they recorded contacts that they couldn't immediately dismiss as fish or debris. That early data helped kick off decades of increasingly serious sonar investigation. Throughout the 1970s, a team associated with the Academy of Applied Science, led by Robert Rines, ran extensive side-scan sonar operations across the loch. In 1970, sonar expert Martin Klein, working with that team, recorded results from a 3-day scan indicating large moving objects in the water, along with underwater ridges and cave-like formations along the loch's steep walls that could plausibly shelter something large. Klein's own published assessment at the time was cautious, suggesting the moving targets were most likely 3 large fish, but the raw sonar contacts themselves were never in dispute. Something large and moving had been detected. Then, in 1987, came one of the biggest coordinated efforts in the mystery's history, Operation Deepscan. A flotilla of boats equipped with sonar swept the loch in a coordinated grid pattern, essentially trying to leave nowhere for anything large to hide. The operation recorded several unexplained contacts at depth, contacts that were never conclusively identified. 2 decades later, in 2007, an MIT research team led by Bob Rines conducted another comprehensive side-scan sonar survey of the loch and picked up something at around 324 feet down that they described, almost comically, as consistent with a common toad crawling across the mud. It became known informally as the Loch Ness toad, a reminder that a lot of these sonar contacts, even the strange ones, eventually get explained by something far more mundane than a monster. But not all of them. In 2011, a commercial tourboat operator working with researcher Adrian Shine picked up a sonar anomaly at the loch's deepest point that raised fresh questions and was never fully resolved. And more recently, cruises operated by the Loch Ness Center using their research vessel Deepscan, equipped with modern sonar, radar, a hydrophone, and even a holographic camera system, have continued to record what the center itself has publicly described as significant unexplained contacts. In October 2020, marine robotics specialist Craig Wallace, an experienced sonar operator with Kongsberg Maritime who has surveyed the loch multiple times, reviewed one of these readings and stated plainly that the contact was genuine and unexplained, noting it was difficult to tell whether it represented a single large creature or an unusually dense shoal of fish, which he pointed out would itself be considered highly unusual for Loch Ness's typically sparse fish population at the depth. So that's the real, documented backbone of this story. Multiple decades, multiple independent research teams, using different technology, different methodologies, working completely independently of each other, all recording the same basic phenomenon over and over again. Large, unexplained sonar contacts at depth, contacts that don't match known fish behavior, don't match debris, and have never been conclusively identified as anything specific. Which brings us to the AI angle, and to what's actually new here. Over the past couple of years, researchers and technically minded enthusiasts have started doing something that, surprisingly, nobody had really done in a systematic way before, pulling together sonar records from across all of these different decades and expeditions, and running them through modern machine learning pattern recognition instead of relying on human eyes squinting at printouts and screens, one expedition at a time. It's important to be upfront about exactly what this is and isn't. This isn't a single peer-reviewed study coming out of a marine biology department with a formal published paper behind it. It's a newer, more informal wave of digital analysis, largely being done by independent researchers and content creators using AI tools, including large language models capable of parsing structured data to look for consistency across data that was never originally designed to be compared side by side. And when you actually do that, when you strip away 66 years of separate reports written by separate teams using separate equipment and separate terminology, and instead look at the raw pattern across all of it, a few specific things start to stand out. First, there's a depth pattern. The overwhelming majority of the strongest unexplained contacts across every decade, from the 1970s Rines expeditions through the 2020 Wallace reading, cluster in a strikingly narrow depth band, generally somewhere between around 500 and 650 feet, well below where recreational sonar or casual observation would ever pick anything up, but still well above the loch's absolute maximum depth. That's not a coincidence you'd expect from random noise or equipment glitches, because equipment glitches tend to scatter randomly across depth ranges rather than consistently clustering in one specific zone across completely different sonar hardware built decades apart. Second, there's a location pattern. A disproportionate number of the strongest contacts across multiple different expeditions run by completely different organizations in completely different decades have been recorded in and around Urquhart Bay, a wide inlet on the loch's northern shore where the water drops off steeply and where underwater surveys have also identified unusual channel and mound formations along the loch bed. Rines' team specifically spent considerable time in the 1970s correlating underwater profile data around this exact bay. Multiple later expeditions, run by people with no direct connection to that original team, kept returning to the same general area and kept picking up similarly unexplained results. Third, and this is the pattern that tends to get the most attention, when people run this data through AI models, there's a movement signature. Several of the strongest contacts across different decades describe a similar profile. A large object or objects moving at a slow, sustained pace at depth, sometimes accompanied by fast, erratic bursts of movement, rather than the steady, predictable movement pattern you'd expect from something like a static geological feature, a sunken log, or a stationary school of fish holding position in cold water. Now, here's the important part, the part a lot of clickbait headlines tend to skip right past. None of this, even when it's run through the most advanced AI pattern recognition available, actually proves the existence of a monster, a plesiosaur, or any specific creature. What AI is genuinely good at here is exactly what it's good at in most applications is. Like this. Finding statistical consistency across large, messy data sets faster and more objectively than a human manually comparing decades of separate paper reports ever could. It's not inventing a monster out of thin air. It's identifying that the same rough pattern, roughly the same depth, roughly the same location, roughly the same movement signature, keeps showing up again and again across independent data sets collected by different people using different tools across more than 6 decades. That consistency itself is the actual finding, and it's a much more interesting one than a simple yes or no answer to the monster question. Marine biologists who've weighed in on this kind of pattern tend to offer a fairly grounded set of explanations. Loch Ness does contain large eels, and some researchers, including a well-known 2018 environmental DNA study led by geneticist Neil Gemmell out of the University of Otago, found unusually high concentrations of eel. DNA throughout the loch, enough that some scientists have floated the idea of a population of unusually large eels as a leading candidate for at least some of these sonar contacts. Eels moving along the loch bed in the exact depth range where thermoclines and available oxygen levels favor them could plausibly produce a recurring, if unexplained, sonar signature across decades without requiring anything more exotic than an unusually large, unusually elusive fish. Other researchers point to seasonal water displacement, seach waves, which are large standing waves that can occur in enclosed lochs and occasionally produce sonar returns that look deceptively like large moving objects. Skeptics also note something important about the human side of this data. Every single sonar operator involved across 66 years of expeditions knew, going in, that they were specifically looking for evidence of a monster. That kind of expectation can shape how ambiguous data gets interpreted and reported, even by well-trained, honest researchers. An AI model comparing raw sonar returns doesn't carry that same expectation bias into its analysis, which is actually one of the more genuinely useful things about applying this kind of pattern recognition to old data. It strips out some of the human tendency to see what you're hoping to find. So where does that leave things? The AI analysis hasn't found a monster. What it has done is something arguably more scientifically interesting. It's confirmed that the same specific, narrow, unusual pattern, depth, location, and movement signature altogether has been independently recorded by different people using different equipment across 6 different decades, without those different research teams ever coordinating with each other or even always being aware of each other's specific findings in detail. That kind of cross-decade consistency is genuinely rare in any kind of anomaly research, and it's exactly the sort of thing that's easy to miss when you're only looking at one expedition's report at a time, and much harder to miss once you can lay 66 years of data side by side and let a pattern recognition system do the comparing. Researchers who study the loch professionally, including Adrian Shine, who has spent decades investigating Loch Ness through the Loch Ness Project, have generally taken a measured position on findings like this. Shine has long argued that whatever's producing these sonar anomalies is likely to have a mundane, if not yet fully confirmed, biological or physical explanation rather than representing evidence of an unknown large species. But he's also been consistent in acknowledging that a meaningful number of these contacts, going all the way back to the 1970s, have never actually been resolved to anyone's full satisfaction, mundane explanation or otherwise. And that's really the most honest place to leave this story. 66 years of sonar equipment, getting more advanced with every single decade, pointed at the same stretch of dark, deep water, and the result isn't a clean resolution in either direction. It's a consistent, unexplained pattern that keeps reappearing no matter who's doing the looking, or what tool they're using to look. Modern AI hasn't settled the Loch Ness mystery. What it's done is confirm that the mystery is a lot more statistically consistent than most people probably assumed, and that alone is enough to keep serious researchers, not just monster hunters, paying close attention to that narrow, deep stretch of water around Urquhart Bay. So here's the real question worth sitting with. If the same unexplained pattern keeps showing up across 66 years, 6 decades, and completely independent research teams, at what point does unexplained stop being an acceptable answer? Drop your take in the comments, and if you want more stories where old evidence gets a genuinely new look through modern technology, subscribe now, because there's a lot more of this waiting to be uncovered.